This is a video on continuity. The question states, discuss the continuity of f of xy is equal to x squared plus x squared y plus y squared over x squared plus y squared for xy not equal to 0, 0, and 0 for xy equal to 0, 0. So first, away from the origin, we're looking at this top line, which is a rational expression. And as long as x comma y is not 0, 0, the denominator is also not equal to 0. So we can say that the function f is continuous away from the point 0, 0. So for the point 0, 0, notice that a function is continuous as long as a limit exists, and when we plug in the point into our function, the value of the function is supposed to be equal to that limit. So let's find out if this limit exists. I see an x squared plus y squared in a few places, so I'm going to use polar coordinates. So I can say that this limit is equal to the limit as r approaches 0. The x squared plus y squared on the outside becomes an r squared. This x squared y, well, x is r cosine theta, y is r sine theta. I can collect the r's together. I get an r cubed cosine squared theta times the sine of theta. And then the denominator, x squared plus y squared, just becomes r squared. I can divide by r squared. R squared over r squared is 1, and r cubed over r squared is r. So I get that this is equal to the limit as r approaches 0 of 1 plus r cosine squared theta times the sine of theta. Cosine and sine are continuous functions, so I can just plug in my r equals 0, and I just get that the limit is equal to 1. Well, that's good because we have a limit that is well defined, but it's bad because the function evaluated at the point 0, 0 is equal to 0, and 1 is not equal to 0. So the limit as we approach 0, 0 is not equal to the function evaluated at 0, 0. And that says that this function is not continuous at the point 0, 0. When the limit exists, but the function is not continuous, then we say that the function has a removable discontinuity at that point. So we can conclude by saying that f of xy is continuous at all points except the origin, where it has a removable discontinuity. And I'm done with the problem.